simulation is live, and it looks like Dark Knight has breached the digital front door of the server. Relax, Cypher. The intrusion detection system shows he only secured a guest access account. He can't execute destructive commands with those permissions. Glitch? Once an attacker has a foothold, they can probe internal configurations that are invisible from the outside. Guest access is an observation post. The firewalls are now a non-factor. At this moment, internal system rules are the only things keeping this machine alive. To understand the threat, look at the architecture of the Linux user hierarchy. Down here at the base, you have standard user accounts. These users operate under strict constraints. Rules dictate exactly what directories they can read and what programs they can run. They are cryptographically locked out from modifying the operating system's core files. But at the apex sits root. This account controls the kernel, the hardware, and every bit of data on the disk. Achieving this level means the attacker owns the hardware. Dark Knight is currently at the bottom of this architecture. To reach the top, he has to hunt for a structural flaw in the way we've assigned permissions. Because those permission walls block upward movement, he starts by moving sideways. This is horizontal escalation. Dark Knight uses his guest access to compromise an adjacent account, the backup admin. This sideways move pays off. Inside the backup admin's directory, he finds a text file containing internal notes about system maintenance and a list of custom scripts. This operational intelligence identifies a specific path to the apex that wasn't visible from the guest account. The notes point him toward a specific configuration, SUID, or Set Owner User ID. Linux allows standard users specific root-level actions, like changing passwords. The system lets the password program run with its owner's authority, root. This is the SUID bit. When set on a file, the program executes with the file owner's permissions, a mechanism of delegated trust. If a program with this bit is misconfigured, it provides a direct path for a user to execute code as root. Dark Knight discovers that a system administrator left an SUID bit on a utility program that should never have it, /user/bin/find. The find utility has a specific flag, -exec, designed to run commands on the files it locates. Because find runs with root's authority, when Dark Knight uses that -exec flag to launch /bin/sh, the system spawns a new terminal shell, inheriting root status. This is vertical escalation. Within seconds, Dark Knight has jumped from a restricted shell to total system authority. A single misconfiguration on one utility file renders other security measures on the system irrelevant. Cypher, Dark Knight has full control. The server is compromised. Pausing the simulation. Let's look at the defensive countermeasure. To prevent this, we audit. Running find/perm -4000 sweeps the file system to identify every binary carrying that SUID tag. Once identified, we use the chmod command to strip the SUID bit from any utility, like find, that doesn't require it for core system stability. Effective security requires the active, continuous auditing of internal trust and permissions to ensure these gaps don't exist. The vulnerability is patched. Dark Knight's session is terminated. Cypher. There's an automated script flashing on Terminal 3. He left something behind. Booting an attacker is meaningless if they've engineered a way to return. Next time, we deal with persistence.